This is the fifth time I have presented my series, part of series, and sadly my marker is out of ink, so I just can't point. But the thing is, I have written all the things on the whiteboard, so yeah. Firstly, I will state my problem. Well, what we want is actually distribution transport from row 0 to row 1. And their random variables, of course, we name that x0 and x1. So the problem would be the transport between the distributions where we can sample from row 1, and what we want is we want to get a sample from our target distribution, namely row 1. How can we describe, how can we model, how can we express this problem mathematically and properly? Well, here it is. It's stochastic interpolants between two distributions. It looks like a bridge. Here's the function I about t, x0 and xi, x1. There's a thing need to be noted that x0 and x1 is actually jointly distributed. Meanwhile, gamma t is a function about t, and z is a normal distribution, and it is independent on the joint distribution x0 and x1. Now we can describe this problem, mathematically. But here we met another obstacle is we can see that xt is actually stochastic path. Well, we use xt to note the intermediate state, but it's actually really kind of random because there's item to describe this randomness. So to perform this process, we need to sample x0, x1, and t, not t, and z from the joint distribution. But what we only can do is sample from row 0. So we need a solution. But before the introduction of the solution, I like to convert these problems. I think it is out of mathematical strict consideration. So we can convert our distribution to density function like this. We start from density function at t equal to 0, which is row 0, and we convert to density function in time equal to 1, which is row 1, and intermediate transport states, we call that row t, of course. So the solution of our problem stated is transport equation introduced by stochastic interpolants. This transport equation is about rho, which is a density function on t, and velocity. Here we know that velocity is b. Velocity is a function only depend on t and xt. It uses conditional expectation to eliminate the random variables that we cannot sample. So the velocity is defined as the conditional expectation on derivative of xt given xt equal to x. So how the velocity and the transport equation can help us to solve our original question? Well, here's another thing. In terms of velocity, the study designs an ODE, which is also actually very simple, but they made that. We can solve our problems by integrating this ODE. But how? As I mentioned, the velocity use condition and use expectation element this random variables that we cannot sample. So it only depends on xt and t. Xt we can present by integrating the ODE from x0 we can sample from row 0, and t belongs to 0 to 1, which is already known. So here it is. I would present the process to solve this as well. We got x0 and t equal to 0, so we got the velocity x0 and 0. We use this velocity to integrate this ODE, so we got x one divide n, n's 1, first n. Yeah. And after few steps, it becomes to x1. And our transport equation, it actually describes how the transport between distributions move. It can guarantee that the final result is exactly a sample from row 1. A lot of ink. That's all. That's the only part of series. And I guess tomorrow I'm going to present how can we approximate the velocity. And then we still have analysis which hasn't been presented